let's look at this warm-up really quickly. This is one of those warm-ups where you cannot solve it without the answer choices. Because honestly, which ratio can be used to solve for A? You can set up many ratios to solve for A because you know all the sides. So, and honestly, you wouldn't, well, yes, you would use it on this triangle, but that is a Pythagorean triple. So let's, what you do first is you circle the angle and you label all the sides compared to that angle. Adjacent, opposite, and hypotenuse. So, let's set up all the ones we could set up. Sine of A would equal opposite 12 over hypotenuse 13. Cosine of A would equal adjacent 5 over hypotenuse 13. Tan of A would equal opposite over adjacent. So I guess you could just set up all three and then see which one of those matches your answer choices. What is it? Dun, 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 dun. B. Very good. So all of these, they got that ratio incorrect. They used the wrong numbers, or it's the reciprocal, or so on and so forth. Now, if I wanted to actually find the angle, what would I press in my calculator to find the measure of angle A? So you'd press second cosine, and it'll look like this. Cosine -1, and then you put 5 divided by 13. Make sure you're in degree mode, because if you're in radian mode, you'll get the wrong answer. Okay, Johan wanted a quick review of how to solve them. So there's a few situations. I'll just use my same ones. So I think a lot of you know how to set up the equation, opposite over adjacent, so katoa, but you might have forgotten how to solve. So you always look at where the variable is. You always look at where the variable is. If the variable's in the denominator, you divide. Denominator, divide. If the variable's in the numerator, you're going to multiply. So on this one, the variable's in the denominator, so you put the 5 first. That is important. Times tan 27. Don't ever let the 27 in the tan separate. Do not separate, because those are super glued together. Denominator divide. Sorry. And then if x is in the numerator, you multiply. So I thoroughly confused you there. Sorry. Denominator divide. 5 divided by tan 27 versus 5 times tan 27. So you look at where the variable is and go from there. All right? So similarity to me was the thing that you needed the most review over. We haven't been using that very often, and it's been the longest since we've learned that. But the next thing that I think you need to focus on as you're getting ready for this test is the quadrilateral properties. I know you know these quadrilaterals, but you might have forgotten some of the obscure properties of them. Remember how the family tree works? A shape has his properties and all of the properties above him. So like a rectangle, sure, a rectangle has 4 right angles, and it has congruent diagonals, but it also has all the properties of a parallelogram, which are like opposite sides parallel, opposite sides congruent, opposite angles congruent, so on and so forth. So a shape has his properties and all of the ones above them. What else do I want to say about this? We're going to go over the properties by just going through some slides. So let's do that, and if questions arise, then we can look at those. Okay, in a math game, David was given the following clues and was told to guess which quadrilateral the clues are describing. The quadrilateral has at least 1 pair of parallel sides. The quadrilateral has at least 2 right angles. So what shapes was he describing? A rhombus has 0 right angles, so it's not this one. It's not the rhombus. Triangle? You're funny. Rectangle. A rectangle would be one of them. A rectangle has at least 1 pair of parallel sides and at least 2 right angles. And then, of course, yes, the square. The square would also have at least 1 pair of sides parallel and at least 2 right angles. Why would a trapezoid not work? It has at least one pair of parallel sides, but it doesn't have at least two right angles necessarily. It could, though. Could it? Could a trapezoid have right angles? But that's not the picture that's drawn there. I drew my own picture, so the answer is not the one that's there. But in the picture I drew, it did fit the qualifications, right? So you have to be careful. And then definitely not a parallelogram because it would not have any right angles if it was just a plain parallelogram. Name the quads that have the following property. Name the quads. Try to do this without looking at the chat. Try to do this by yourself. Can you name the quads? There's two of them. That's okay, Johan. You worked ahead. There are two of them. Rhombus has all sides congruent. And of course a square. A square has almost every property, almost. So square is going to be the answer to a lot. Okay? Name the quads that have the following property. This one's a little bit tougher. You might not have remembered this one as well. Don't type the answer quite yet, please. The diagonals, what does that symbol mean? Bisect the angles. Yep. So believe it or not, the answer to this one is the exact same answer as the last one. This is not going to be a rhombus, sorry. But in a rhombus, the diagonals bisect the angles. And in a square, that was a bad square as well. The diagonals bisect the angles. We even know the exact angles. They're all 45. So anyways, in a kite, I would not write the word kite as my answer because only one diagonal bisects the angles. The other diagonal doesn't. And it definitely doesn't in a rectangle. In a rectangle, the diagonals are congruent. They're the same length, but they do not cut the angles in half, so be careful. Okay? Isosceles trapezoid. Nope. Nope, nope, nope. That angle did not get cut in half. One of them is bigger than the other, so no, no. Yeah, you need to go home and study your chart. Yeah. I hope you kept the chart. Consecutive angles are supplementary. Which quads fit this property? All parallelograms. So parallelogram, rectangle, rhombus, square. Parallelogram, rectangle, rhombus, square. All parallelograms have consecutive angles supplementary. Only two pairs of angles in a trapezoid, Victor. So I wouldn't say trapezoid because it's not all of his angles. It's only two of them. Okay? All the parallelograms. Good. Name the quads that have the following property. There's two. Well, no, I'm sorry. There's three. There's totally three. Good. Kite, rhombus, square. Kite, rhombus, square. So anytime you see any of those figures, it is your responsibility to add the 90-degree angle markings yourself when you see a kite, a rhombus, or a square. Diagonals are perpendicular. It's your job to know that. Which of the following dotted lines are lines of symmetry? C and D are the only ones that are lines of symmetry. This could be, we don't know it's a square, so this is a rectangle. If I draw a vertical line down the middle of a rectangle, it would be a line of symmetry. If I draw a horizontal line, well, if I draw the diagonal of symmetry of the kite, it's obviously a line of symmetry. This one is the top congruent to the bottom. No. If I were to flip this over, I would get this. That's not a line of symmetry. It has to be a mirror image. It has to look the same on one side as the other. If I flipped that parallelogram over, it would not be symmetrical. Victor, we had to assume they were in the middle. Sorry, we just had to assume that. Okay. So that's the end of the lesson today. It was super short. We're going to do this Connect 4 game in class, but please make sure at home you're doing DPM review number 2 and you're checking the answers online. Every problem. Don't skip any. We can't be too sure. We don't want to miss. Any problem you miss on the DPM is -5, half a letter grade. So we want to make sure that we get every single problem right, nothing less than 100.